Today, we will be discussing some basic concepts in digital image processing. Now, first we deal with how an object is perceived. How we perceive an object. First, there are some features of the object that is grouped. All the features are grouped, and then an object is identified, and combining many objects, a particular scene is identified. Now, what do we do with all the visual information that we have? There are two types of processing. One is the bottom-up processing and the other is the top-down processing. In the bottom-up processing, we have first the features are identified. All those features, they form a group and a particular object is formed, and many objects combine to form a scene, and then that scene is identified, and then the brain, it works according to the scene. The brain makes some decision. That means first the sensing is done and then the brain acts. The other is the top-down approach. In top-down approach, first the brain, it takes some decisions, and then it sends, the brain, after taking the decision, it sends the message to the body parts, and then the parts work accordingly. In the top-down processing, we have an example is walking to the refrigerator in the middle of the night. That means first the brain decided that it has to move up to the refrigerator, and then the command was given to the legs to move up to the refrigerator. First, the perceiving was not done. Object was not perceived and identified in the brain. No, that was done in the bottom-up approach. That means the object was identified and then the brain worked according to it. That is the bottom-up. In the top-down, first the brain gives instruction and then the body goes and identifies the object. Now, how an image is formed in the eye? We have a particular object, and then this object, and this is a eye, and we have a particular object. The eye perceives the object. The eye has a lens, and that lens works in the same way as a hardware lens works. So, as a lens works, normal lens works. Similarly, the lens in the eye also works. It first captures an image, and then that the image of the object is formed. Now you can see the graphical representation of the eye, which is looking at a palm tree. Now these are some lens parameters that we have. Similar are the lens parameters with the eye also. We have the focal length 1 upon f equals to 1 upon s1. s1 is the distance of the object with the lens, and s2 is the distance of the image plane with the lens. These are the light and the electromagnetic spectrum. That is, we have the wavelength, radio waves, microwaves, infrared waves, visible rays, UV rays, X-rays and gamma rays, and the wavelength is also given. And this is the frequency in hertz. Wavelength is in meters. Now there is some relation among the wavelength, frequency and the energy. Wavelength is lambda, denoted by lambda, frequency is denoted by v, and energy is denoted by E. Now this wavelength is equals to the velocity of light c divided by the frequency. E is the Planck's, E is the energy. Energy is given by h, the Planck constant, multiplied by the velocity. Now the light and the EM spectrum, we have a term known as diffraction limit, which is that what is the size of the object which you can perceive, which you can see. That is known as the diffraction limit of diffraction. That means till where the diffraction is not done, until there you can see. So that is the diffraction limit. Now how image is sensed and acquired? Any image, we are not talking about the human eye, we are talking about any lens. So how that image is sensed and acquisition takes place? Any object that there is, every object emits some kind of energy. Now that energy is captured by a sensing material. It is sensed by some sensing material, and then some voltage is generated according to the energy which has been sensed, because energy is there, it has some power and it is generating some voltage. Now voltage is in the form of waves. It is an analog signal, and this voltage is then digitized. We do a digitalization of this voltage, or the waveform of the voltage which is sent. That is, up till the voltage everything is analog. Now this voltage is, we are capturing, we are now converting this voltage, this analog signal into the digital form, that is digitizing this particular response of the voltage. Now we come to an image. Now image is a 2D function which is a function of x and y, where x and y are the spatial coordinates. F of xy is the intensity of the gray level. A digital image, fxy and f of xy are all finite. For example, x belongs to 1, 2 up till m, and y belongs to 1 till up till n. Why m and n? Because we have total number of pixels are m multiplied by n. F of xy is 0, 1, 2 up till 255. Digital image processing is processing the digital images with the means of a digital computer. Each element xy in a digital image, it is called a pixel. Pixel is the short form for picture element. So every when we see an image, every pixel, that is the each and every element that is in the form of x and x and y are the specific coordinates. Now you just pay attention here that when we talk about the coordinates, this is the x coordinate and this is the y coordinate. Instead, y is not up, y is 0 to downwards we have when we talk about the coordinates in the x and y direction. Generally in graph we have upside y axis, but here we have the downside y axis. Now simple image formation model, f of xy ranges from 0 to infinite. F of xy ranges from L minimum to L max, where L minimum is I minimum multiplied by R minimum. Now what is image sampling and quantization? Now this is a continuous image. The first image, it is a continuous image, then that means it is a captured image. So this captured image is then, it is a continuous image. This is then used to, that means this is the actual image that we are seeing. B is the scan line from A to B in the continuous image, which illustrates the concepts of sampling and quantization. C is the sampling and quantization, what that we are doing upon this image, upon the B1, and then D we have the digital scan line. Sampling is digitizing the coordinate value, which is done, coordinate values, how are they acquired? They are acquired by the help of some sensors. And quantization is then digitizing these amplitude values. Now here we have the image sampling and quantization in a sensor array. This is the image, continuous image, which is projected on the sensor array, and the second image, it is the result of image sampling and quantization that has been done. Now what is the dynamic range? We have a function of xy, which is ranging from L minimum to L max generally, and L, this we have done previously also. Dynamic range and contrast ratio, it is the ratio of the maximum detectable intensity level. That means whatever intensity of the pixel, which is the maximum value, to the minimum detectable intensity value, that is the noise. So that is I maximum intensity divided by the minimum intensity gives us the contrast ratio or the dynamic range. Now how we represent the digital image? Function of x as xy, x ranges from 0 to m minus 1 and y ranges from 0 to n minus 1. Why n minus 1? Because y we have total pixels 0 up till n, and x we have total the range is ranging from 0 to m. So we have m, not 0 to m. In x we have m, the maximum m pixels, so range is ranging from 0 to m minus 1, and in y we have n pixels, so the value is ranging from 0 to n minus 1. So x and y, the spatial coordinates, they are called in the spatial domain. It is suitable for visualization and then processing and algorithm development. Now this is how we store an image. All the values of the pixels have been mentioned. Now we come to spatial resolution. Spatial resolution, this is the smallest details, that is the lines per unit distance, or the dots or the pixels per unit distance, that is per pixel per unit area. How many pixels we have in 1 unit, that is the 1 unit area, that is the spatial resolution. The spatial resolution doesn't mean that if the image is large, then it will have a high spatial resolution. No, then it depends upon how many pixels are there in per unit area. Now we can see on the right hand side there are the images of 4 watches are there, and all the images are of the same size, but the dimensions are same, but the resolution is different. Okay, the resolution for the first image is 1250 dpi. Dpi is dots per inch, which is used in US generally. Then the second image adjacent to the first one, it is the resolution is 300 dpi. You can see it is not as sharp as the first one. The third one, which is downside of first one, that is it is having the 150 dpi, and the last image it is having the dpi of 72. You can see the difference between the last one and the first one. Okay, so there is a lot of difference between the first and the last, because there is a lot of difference between the number of pixels per unit area. The first one is having 1250 dpi and the last one is having 72 dpi. Now, intensity resolution, it is the smallest discernible change in the intensity level, is called the intensity resolution, using the number of levels of intensities. Then there are certain type of curves that are known as the isopreference curves, which vary the spatial and intensity sampling simultaneously. If the spatial and the intensity sampling is varying, then the curves which we get, these are called the isopreference curves. There is basic, set and logical operations. The basic are the, suppose we have some, now what is this? That means we have having the pixels, and the pixels are ranging from 1 to 255. So these are the range of the pixels. So A is an element, A belongs to A, or it isn't an element. It is a subset, can be a subset, there can be union, there can be intersection, there can be disjoint or mutual exclusive. So these are some operations which are performed on the pixels. There are some basic relationship between some pixels. That means we have neighbors of the pixel. Suppose we have a pixel xy, then we have the immediate 4 neighbors are known as the 4 neighbors, that is n4 of p. P is the circled one that is xy, this is p. Okay, pixel p. Now, what are the 4 neighbors of this xy? The 4 neighbors will be immediate top, immediate down, immediate left and immediate y. Similarly, and these are the coordinate values. If our concerned pixel is xy, then the top pixel will be x minus 1 y. Here it will be x and y plus 1. Down it will be x plus 1 y, and left it will be x and y minus 1. Diagonal pixel, diagonal are the left diagonal up, right diagonal up, left diagonal bottom and right diagonal bottom. And what will be the 8 pixel, 8 neighbors? The 8 neighbors, first we have seen the 4 neighbors, then we saw the diagonal neighbors. The 8 neighbors will be combination of the 4 neighbors and the diagonal neighbors. That means 4 of the immediate neighbors and 4 of the diagonal neighbors will give us a total 8 neighbors. That means all the possible values of the neighbors of that particular pixel xy. That means we have top down, left right and diagonal as well. Top diagonal and bottom diagonals, top left, top right, bottom left and bottom right. And there is adjacency in the relationship between 2 pixels. There is a V is a set of intensity values which is used to define adjacency, binary image and gray level image. There are 3 types of adjacency, 4 adjacency, what we saw just now, 8 adjacency and M adjacency.